Hey, welcome back. This is the next lecture on index settings and mapping. So it's sort of a continuation on the previous lecture. I had to cut it short because it's getting too long. So let's continue. So since I deleted this index, we don't have any documents in here. Let's input a document into this index. Let's index a document. So we need the put command. We specify the index, which is customers, and then we specify the type. Right now we only have online, and then let's give the ID 124. And now I'm about to add this document into this index. Notice this document has one additional field. All right, we've got name in the structure, we've got gender, age, total, and is new. These fields are in this index schema, the structure, but this address field hasn't been added yet. What's going to happen if I do this? Let's hit play and notice nothing happened. It's successful. We were able to index it. The document was created. So Elasticsearch is not really getting in our way. When we have additional fields, it will, figure out what the data type for that field should be and index it appropriately. It's not going to restrict us and say, hey, you defined this index structure a certain way and now you have this additional field. What do you want me to do with it? It's going to take additional fields that we give it and modify the structure. And again, by modifying the structure, what do I mean? I mean that it modifies the mapping. Right, it updates the mapping to include this new field that's called address. And which mapping did it update? It updated the online type mapping, okay? So now if we do a GET request on customers, you'll notice that in the mapping for the online type, the additional field has been added. And that's right here. Notice the address field has been added to the online type. Now, you may or may not want Elasticsearch to behave this way. In production, I would not recommend it. I would like Elasticsearch to behave very strict and make sure that the document that we send to Elasticsearch for indexing matches exactly the schema or mapping that we have already defined. So to enforce this, Elasticsearch by default behaves in this dynamic manner, but to force strictness, we have to specify that during index creation and say, hey, this particular mapping has strict structure. So no dynamic mapping. Make sure it's strict. Any new fields will be ignored or some error will be thrown. Okay, so we can do that at index creation time when we're first configuring the index with the particular mappings. Or we can add this rule for being strict after the mapping has already been created. It's just a configuration change that we need to apply on a given mapping, and I'll show you how to do that. So there's actually a property that you can set for the given mapping, and that's called dynamic. And we could change that dynamic field to either false or strict. If we set that to false, that causes unmapped data to just be ignored. It won't even be indexed, and the structure will not be modified. If we change the dynamic field to be strict, that's going to cause the unmapped data that's coming into Elasticsearch to throw an error. Okay, so it depends on what you want to do. I think setting dynamic to false is best. That's just going to ignore any additional fields that are coming in. But if you want logging and you want to be able to catch that error and log it and say, hey, somebody tried to index this additional field, you can choose dynamic to be strict. So how do we set this dynamic field on a given mapping? Well, that's actually pretty straightforward. I can modify the mapping by doing customer/_mapping and specify the given mapping. Let's say we've already got the online mapping type. So let's modify that. And then we give the field dynamic is equal to false, like that. Whoops, we don't need that semicolon at the end. Too used to Java. Okay, so no semicolon at the end. Just hit play and there you go. We've added this dynamic property to the online mapping of the customer's index. So now false again means that unmapped data that's entering the index is just going to be ignored. If I change this false to be strict, let's hit play. And there we go. We applied that field to be strict. Now this is going to restrict any documents with fields that are not on the mapping. All right, and it's not only is it going to restrict those fields from being indexed, it's also going to throw an error and let the user know that, hey, you're trying to index a document that contains a field that is not allowed, that the field doesn't exist on the mapping. So let's take a look at the mapping for customers now. let's just do a get on customers and hit play. Notice that the dynamic property has been set to strict, meaning that if we try to index a document that has an additional field that the mapping does not recognize, it's going to throw an error. So let's test this out. Here I have the document that I want to index. Address, gender, age, these fields are already in our index, in the index structure, in the mapping. But if I add another field, let's call it retired, if this customer is retired, whatever, it doesn't matter what field it is, and let's just call it true. If I try to index this, let's hit play. Notice it's going to give us an exception. It's saying strict dynamic mapping exception. Mapping set to strict dynamic. All right, so it's throwing an exception, it's giving a 400 status code because we modified the mapping to be strict for the dynamic field. Now coming over to analyzers, we spoke about analyzers in the previous lesson as well as the one before that. So there's a way to test the analyzers and see how they work. Let's go visit the Elasticsearch documentation on this. If you type in Elasticsearch analyzers in Google, and the first link here, the Elasticsearch reference, just click there, and this will take you to the analyzers page. All right, and feel free to browse around this documentation. I think it's one of the best documentation that I've seen for big data technologies is Elasticsearch reference. So check it out. But anyway, in the analyzers section here, you see that there's a standard analyzer, there's a simple analyzer, white space analyzer. So review all of these and see what they do. And there's a way to test these out. If you go to the page before this page, which is right here, testing analyzers, it'll show you that there's an endpoint and the _analyze endpoint, this URL that you can put into the console, Kibana console, and test these things out. So for example, let me just copy this and paste it into the Kibana console. There's not really a URL. This is an endpoint extension to the URL, but this is going to test against our running instance of Elasticsearch how the white space analyzer works if we provide this text. Okay, so if you hit play, notice that the tokens get broken up on white space. All right, notice the first token is the, and it gives the position of where that ends and where it starts. So the start offset is at the 0th position. This is the 0th index position, all the way up to this 3rd index position. That's where it ends, this end offset. And then the word quick, we've got the word brown and then the word fox. So notice how it's breaking these terms on white space and specifying that where they start and where they end, and it gives a position of the actual word 0, 1, 2, 3. So there are 4 words here, starting with the 0th index position, and these are all referred to as tokens. Right? That's what each one of these terms are. They're tokens. So that's the white space analyzer. There's also the standard analyzer. Okay, and this is the one that you're going to be using most often. And like I said, the standard analyzer is going to split on white space, but it's also going to lowercase all of the terms and split them on white space. So let's hit play and notice that the word the token the, I'm going to refer to these as tokens, is now lowercased. Okay, all of them. And the word fox, right, the period has disappeared. You won't see that in there anymore. So punctuations are removed. The capital words are converted to lowercase. So that's the standard analyzer. There's also something called the simple analyzer. Let's change this to simple and you'll see what happens. Let's hit play and notice the simple analyzer works almost the same way as the standard analyzer, except that it splits on not only white space, but also it splits on anything that's not a letter, such as numbers, for example. If we have the word, brown 746 and the word quick 984 or whatever, right? This is considered one term. If we use the standard analyzer, let me change this back to standard. If we use the standard analyzer and hit play, notice that quick 984 is considered one token, right? The word brown 746 is considered, one token. There are 4 tokens here. But if we change this to simple analyzer and hit play, it splits on not only white space, but also whenever it encounters a character that is not a letter. Okay? and of course it lowercases all the terms. So instead of 984, I could have had, a colon and a semicolon here. Let's hit play. Notice it didn't even register these semicolons here, okay? Whereas if we were to use a white space analyzer, right, that's going to only care about splitting on white space. So notice this quick with the semicolon and colon has made it into the token, and so did the Brown 746. So look through these, test these analyzers out here. If we go to the next page where it says analyzers, you'll be able to test out each one of them. There's the English analyzer. So let's go back. Let me show you how that works. So if I change this to English, let's hit play. Notice, it didn't recognize this quick with a colon and semicolon as an English word. It just basically eliminated those colons and semicolons and just left with quick. All right, that's what the English analyzer could do. Brown 746 is considered the entire term, and the punctuations, such as a period, is also removed. You don't see that in Fox. And one obvious thing you'll notice is this is only tokenizing 3 terms. Notice that the word the is removed because that's considered a stop word, right? So it's going to remove stop words. That's what English Analyzer can do. Now remember when I talked about stemming, right? Let's say if we have a word such as running, right? The stem of this word is run, just run. So this English Analyzer can actually eliminate the extraneous words here because running and run pretty much mean the same thing. And when a user is searching for the word running or run, they probably mean the same thing and they're not interested in the past tense or present and so on. So with running, if we hit play, notice that only run is registered as a token. And notice the start offset and the end offset is the distance between the entire word running. Okay, you can actually count each one of these spaces and you'll see that it registers the offset at 7 characters, but the actual token is only the word run, all right? And for example, for Fox, if I change this to Foxes and hit play, it only registers Fox, right? Notice the offset, the end offset is taking into account the positions for the entire word, right, from 18 to 23, but it only registers Fox as the token. So when a user searches for the word foxes, it will match Fox. When the user searches for the word running, it will match run. That's the English Analyzer. And similar to English, there are various languages you can search for here in the Language Analyzer. In the documentation, there's, Arabic and Armenian, Italian, Spanish, Swedish, Thai. There's just so many different language analyzers that Elasticsearch supports. It knows the different stop words of different languages and past tense, plural, those sort of semantics of languages. The language analyzers have been built with that type of knowledge. But we're only going to be dealing with the English Analyzer here. So definitely go through this documentation and understand how these work. Test them out. This testing analyzers section is very helpful. You can see that you can use filters to specify whether you want lowercasing and the kind of text that you want processed. And then down here, there are some other examples. Now, coming over to Custom Analyzer. All right, notice it says, alternatively, a custom analyzer can be referred to when running the Analyze API on a specific index. So you can define your own analyzers. For example, here, the analyzer called stdfolded has been defined, and it's in the settings section of a particular index, right? Notice in the settings section, right? This is where we define stuff like the number of shards and the number of replicas. In here, we can specify an analyzer. We can define our own analyzer, and that's going to go into this analysis section. Inside of analysis, we have an analyzer section, and inside of analyzer is where we define the name of our custom analyzer that we are trying to create. So in here, notice the type is custom. Tokenizer, it's going to use a standard tokenizer, meaning it's going to divide the terms on word boundaries such as, white space and so on. And the filter that's being used here is going to lowercase. So it's going to lowercase all of the terms. And it's doing ASCII folding. You can Google this on your own when you get a chance. And then down here in the mappings, when we specify the particular mapping, which is going to be called my type in this example, in the properties where we define the fields, this field called myText has been given the analyzer std_folded. That's the analyzer that we defined in the settings section of this index, right? That's this guy right here. So we can refer by name to this custom defined analyzer in the mappings, for a particular field. So that's what this is doing right here. The std_folded analyzer is being applied to the myText. And this is going to happen not only during query time, but also during index time. And then if you want to test this analyzer that you defined, called std_folded, if you want to test it specifically, you could just specify the index in which that analyzer is defined, and then use the _analyze endpoint, and then specify what analyzer it is that you want to test out, and that's this guy. And then we specify the text that we want to run through this analyzer so that you can see how it's tokenized. Okay, and of course the way things are tokenized is important to understand, because that's what's going to make its way into the inverted index. The text is going to be formatted based on the analyzer that we defined for a particular field. And the data in that field is going to be put into the inverted index so that it is searchable. So here the analyzer is going to be applied not only during indexing, but also during searching, so that we can match on the different tokens that have made their way into the inverted index. Okay, so read through both of these. It's part of this lecture. I want you to, before moving on, as a matter of fact, here in the anatomy of analyzer, one step back, and you can go one more step back, this analysis section, index time analysis, and then there's also search time analysis. Go through some of these topics and then read through the anatomy of an analyzer and then testing these analyzers, and then go to the analyzers section, read through all of these before moving on to the next lecture. So for now, I'm going to wrap up this lesson. Thanks for watching. I'll see you soon.